ございます。ちょっと時間が日が空いてしまいましたが、朝のHoudini作業配信をやっていきたいと思います。今日はちょっと前回カメラがおかしかったのがうまく表示ができなかったところで止まってたい部分の続きをやっていきたいと思います。放送の前回の配信の後ちょっとすぐ調べてみたところ、カメラがおかしかっただけで、前回この白い部分が全く出ていなくて、ちょっと意味がわからなくてどうなってんだってなったんですが、ホームポジションに戻るだけで普通に出てしまったので、多分動かしてるうちにカメラがおかしくなってクリッピングされてたのか変なことになっていたっぽいです。なのでロジック的にはほぼ特に問題はなかったので、念のためちょっと振り返ってみるとまずグリッドを作って、でリメッシュかけて、三角のメッシュにして、ではカラーで暗めの黒に近いカラーを与えてあげます。でポイント数をディテールですね。ディテールにポイント全体のレングスを入れておいてあとはここからfor eachをやっていきます。でこの辺はあとはもうほとんどベックスなんですが、無作為に5つかな、5個の焦点を選んであげて、そこだけのカラーを変えてあげて、でコピートゥポイントでそこにスフィアを生成してあげます。でに対してスキャッターでスフィアをスフィアの頂点にスキャッターしますと。これを中まで配置したいので、表面だけではなくて、バラバラに配置されるように、自前のジッターノードのようなロジックを X で書いて点群を配置してあげて、でそれをグループにして、でスキャッターの時スキャッターした時点のやつとマージしてあげて、ここでグループでまずスフィアのスキャッター部分にエンドの グループを作ってあげて、で、スタートは最初に作っているので、ここか。どうだっけ。ここか。セットポイントグループで、ここか。スタートグループ作っているので、インフォを見ると、スタートとエンドグループができていて、で、それを元に、find shortest pathでつないであげると、こんな風につながって、それと大元の大位置に入力しているメッシュと合成させてあげると、こんな絵ができますと。で、あとは、が変わるごとに、ここの別のロジックでどんどんこれが配置されていくので、というところで、ここの、前回はこれが全くうまく表示されないという現象が起きていて、カメラをホームポジションに戻したらうまく出るようになったというところで、一旦これで前回まではこんな感じです。前回はここが全然つながらなかったので、これで続きからやっていきたいと思います。
Of the functional space, let's say that the start points are start and end points are end, and the mode is from any start to each end. Here we have our 5 systems. So the only problem, if we change the iteration number, we will see nothing, because every iteration, the first node in this block will get the geometry from the last block, and if we change the geometry that way that we will delete the original geometry, it doesn't know what to do in this first block anymore. So therefore we don't want to delete the initial geometry completely. Instead we want to merge them before going to the end, and now we can increase the iterations. As you can see, now we have already something interesting. Let's go back to 1 and let's separate this find shortest path that roots. Let's separate these roots by creating an attribute. An attribute path, which is 1, and let's separate these roots after the loop system by delete the initial geometry by expression. Path is not equal 1. Now we have only the roots. So what we can do right now, let's see. So our main node is set scatter. So what we can do right now, let's see. So our main node is set scatter. We have the total amount of points here. By delete this roots after the loop system, by delete the initial geometry by expression path is not equal 1. Now we have only the roots. So what we can do right now, let's see. So our main node is set scatter. We have the total amount of points here, and we also have this basic length. So let's change it. So you can see that we changing our look. Note please that they're not intersecting each other. That's how the shortest path work. So even if we increase the amount of points, they will not intersect each other, which is fine. And if we now increase the number of the iterations here, we will see that the new iterations will intersect the previous iterations, which is also fine because we have some extra layers now. Also we can change the scatter here for density, and we could change the setting of these jitter points, but we don't have a value for this. So for now we want to, we could do this by multiply this pushing with something like this. But if we want to do this procedurally, we can multiply it by jitter attribute, which is 0 by default. But we can, before the copy 2 points, we can add the attribute randomize node and add here a jitter attribute. We immediately immediately can see the difference. This attribute is one-dimensional, so let's say it's 1. So we can change the global scale now, or we can change the minimum value. As you can see, it's pretty fast, so the system is optimized. Let's now colorize the iterations for better visibility. First we need to store these iterations here, so let's store them in this wrangle. We can do this by creating an integer attribute root num is detail, and we can just read the iteration as we did before. We can read the iteration from the second input, which goes here. So now we have the root number attribute here. Let's use this attribute for colorizing. So let's append a color node, and let's say that color type is RAM from attribute. The attribute is root num. This attribute, actually, if we go in the geometry spreadsheet, we can see that root num goes from 0 to 4, so it has 5 total numbers. Based on our iteration,
なんで入ってきてんだ。ディティールの値がないな。どっかでディティール消されてね。
actually, if we go in the geometry spreadsheet, we can see that root num goes from 0 to 4, so it has 5 total numbers based on our iterations. So we can copy this parameter and paste it in this range here, paste as a relative reference, and let's change the end color to the red and the first color to the green, and now we can visualize our iteration. The more iterations we have, the more, so we can see the difference between them now. So now let's change the colors to some more interesting colors. Let's say it's more warm colors, and let's add more contrast here. Now we have one problem. The problem is the overlapping points. So as you can see by these numbers, they are overlapping. Each other, so I can show you this a different way with the point jitter. If we increase the scale of the point jitter, you can see that every point actually has more than one point. It can be even beautiful, but that's not what we desire right now, so let's get rid of this. So we can do this with clean, and inside of clean we can consolidate points and fix overlaps, and we don't want to delete overlap pairs. So now it's okay, but so before we had 25,000 points, and now we have only 3,000 points, which is better, but we have another problem. If we have only 3,000 points, which is better, but we have another problem. If we will subdivide our geometry, so it looks okay, but when we append a point jitter, we can see that some of these points are again not fused together. So clean didn't do this for us, so I don't know why, but so some of these points, it looks okay, but when we append a point jitter, we can see that some of these points are again not fused together. So clean didn't do this for us, so I don't know why, but I know how to fix this. So let's fix this by converting this to line. So how it works? So before, if we show the display primitive numbers, so we turn on this checkbox, and we can see that each root, each line actually has its own number. So, and after the convert line, we can see that now each straight line, each straight segment has its own number with an overlapping inside, but that's how the clean works. So we can now clearly see that it's now changed. And now after the subdividing, if we append a jitter again, we can see that there are no more overlapped points, which is better. And instead of, so let's get it, which is better. And instead of let's get rid of the convert line. instead of 44,000 points, we have only 15,000 points. So let's now open the instead of 44,000 points, we have only 15,000 points. So let's now open the polywire, and polywire has scale, the wire radius. So let's do this procedurally. So let's put down a resample node. Resample node will help us to create a curve view attribute, which is from 0 to 1, which represents the length of each line. And we don't want to subdivide this anymore, so we don't want to check this maximum segment length checkbox. So let's append it after the color but before the convert.
何も変わんないよ。あ、カーブを入れたかったってことか。
Line. Now we can see this curve view attribute. Now we can use this curve view attribute as a p-scale. So let's first make sure that p-scale is used inside of this polywire node. It's used, but it's 0 by default. So
B スケール入ってん
we'll set p-scale here. We can say that p-scale is channel float, floating channel is a width. So now we can manipulate this. So this is our width, and now we can remap this over width with a multiplying by the curve view attribute. And now we have the roots. The roots are thin at the end and thick at the start. If we want to invert this effect, we can subtract the curve view from 1, and now it looks like this. And before we continue, I want to now it looks like this. And before we continue, I want to do another thing. I want to make the colors more bright. So bright, here we can type cd is multiply with a bright value, which is float. So we can multiply this by 1, for example, or by 2, by 4, or something like whatever we need. So 2 is okay for now. So let's create the test geometry squab. Let's just make sure that its scale is nearly the same. For we don't need to change the scale system here. So let's remesh it. Let's plug into the PT amount and let's see what will happen. So we can see immediately the result. Let's play with parameters. Let's increase the iterations. The more iterations we have, the more details we have. Let's increase or decrease the amount. Say if we say it's 1. So we have an interesting patterns. If we set this to 30, we see more chaos. So let's say it's 15. Let's put it somewhere between. So let's maybe decrease a little bit the p scale. And we can also play with this randomize. So let's say it's set jitter. Jitter. So let's play with this jitter. We can increase these values or we can decrease these values. So I think in this case it's better to increase these values. Something like this. And the important thing that if we go closer, we can see that each connection is clean, so we don't have intersections here. We have fine connections between each roots. This is because of our clean system. Okay, we are ready to render, but before rendering I want to change some shape of the node. I want to play around with this, and I will show you how we can do this. So let's create a grid and remesh it as we did it before, and let's append a find shortest path with a manual selection of points. We will select start points is 0 and end points is 1, 2, 3, 4, 5, 6 points, and the mode is from any start to each end. So, and for working we also want a sorting node just for randomizing the point order random. So now
そう。メッシュかける前のポイント使ってんの？
you can see the simple shortest path system. What it actually does, let's show the geometry. It tries to create a shortest way from the start point and the end point, and this way is relatively straight. So this line is relatively straight and all the lines is relatively straight. How we can change their shape? we can change the cost of each edge of the initial geometry, so some of the edges will cost more than another. So how we can do this? We can create attribute create and name it cost, and the default value is 1, so each edge will have the same cost, which is 1. And let's activate the point cost attribute here inside the shortestpath node is cost. So, and let's now modify this cost. Node is cost. So, and let's now modify this cost with randomizing this. No, not randomizing, with a noise. It's better. Because we will have a certain pattern. So let's noise the cost attribute, and we can visualize this attribute here. So we can see that now we have some heterogeneity. So we have some noise. Let's see how it works. Let's play with element size. Let's play with amplitude. And now you can see that before and after we have the shape changed. So let's copy these two nodes to our geometry and delete this. So let's and after, and now you can see that before and after we have the shape changed. So let's copy these two nodes to our geometry and delete. Delete this test in geometry. And let's see how we can play with this. So I'm turning off the visualization. So, and let's see what will happen. So we have to activate in our define shortestpath node point cost attribute. And so let's play around. So let's make maybe the element size is smaller. Yes, okay, so now we see the more curly effect. For better visibility, we can also change the remesh, and that's also the way how we increase the detalization of the whole system. Let's make the target edge length the half. So now you can see that we have a pretty good detalization. I wonder if we can even make it even smaller. 0.07 should be enough. Okay, now we have a pretty awesome detalization, and as you can see with this curly effect, let me show you the difference. So before we append the point cost attribute, it looks like let's wait a little. It looks like this. So we have more straight lines around the geometry, and after the appending the cost attribute, we will have more curly look, which is good. Let's render it now. So let's append a null here and name it out roads, which is a good practice for rendering. Let's go up and rename the current node as a routes setup. Let's wait a little until it's ready with all the calculations inside. Okay, let's now create the new geometry node and let's now create the new geometry node and let's name it as render routes. Let's dive in and create an object merge node here. So, and let's paste here our null. It doesn't work because we renamed the geometry. Okay, let's pick it manually, out routes. So the render geometry is now here. Let's create a material. Now here, let's create a material. Let's create a Redshift material builder and name it also routes. Let's dive in. And create a Redshift incandescent material, which is self-illumination material, and let's create a user. Color user data attribute. And we can use the color of the geometry itself. So now this is our material, and we can use the color of the geometry itself. So now this is our material. Let's select this material in the render routes node. So we have this math route. Now, and now we can go to the render nodes, and let's create a redshift render. So it creates 2 nodes by default. Let's rename it again to root. Roots. So inside the camera is camera 1, so but it doesn't exist right now. Let's create new camera, and it's camera 1 by default. Let's lock this button and change the position of the camera in viewport, something like this. So, and now I can see that inside of the root system I would prefer to change the polywire, the p scale of the polywire a little. So let's decrease the amount, maybe like this. So let's decrease the amount, maybe like this. So let's save the scene, and we can now try to render it. So let's open the render view and press the play button, and after a while we can see this system. And let's play with DOF. Inside of the camera we have a redshift camera parameters and DOF. Let's enable this DOF, and in sampling
何ログインできねえじゃねえかよ。だる。マジか。だる。レッドシフトのログインができねえ。パスワードも忘れちゃったな。どうしようかな。
in menu we can change this f-stop parameter to something else. So the smaller the parameter is, the greater the DOF is. And focus distance, we can also change the focus distance to select our desirable depth of field. So we can make it even smaller, and we can play with the camera position and focus distance again. So, and maybe we can go to the material and increase the intensity multiplier, maybe 2, even 4. And we also can change the contrast inside of the color node. We can make it more dark. But because we are changing the geometry, so now we need to refresh the APR. So I hope this was useful. I hope this is a good tutorial. I hope you like it. If you like this tutorial, you can subscribe, share, like, and so on. And you can also find all the source files on my Gumroad. The link is in the description section. So good luck with good renders, and see you later.
レッドシフトのログインが外れて、なぜかログアウトしてしまっているので、動画だとレッドシフトでレンダリングをしてるんですけど、一旦ちょっとマントラでやってみました。ちょっと前回できなかったので、ちょっと今回はリベンジしたいなと思っていたんですが、ちょっとこれはなかなか骨が折れるさも動画でした。基本的にはシージャルに適用できるアルゴリズムなんだと思いますが、一部自前で微調整する方が良さそうなパラメーターがいくつかあったので、オブジェクトのスケールとかに合わせたりとか、メッシュの細かさに合わせたりとかで、適宜調整みたいな感じかなとは思います。はい。というわけで、一旦配信はここで終わりたいと思います。引き続き、この後レッドシフトでレンダリングしたりとかっていう作業をディスコードの方でダラダラと垂れ流していこうかなと思ってます。はい。では今日はここまでにします。ご視聴ありがとうございました。